All right, let's just jump right in. We're going to go on a little journey here. From the, chaotic, moody skies we see every day, all the way out to the grand cosmic clockwork that runs our entire year. We're going to connect the dots between a single raindrop and the silent, steady tilt of our entire planet.
I mean, you've probably asked this, right? It feels so simple. You look up and wonder, why isn't it just nice all year round? Why do we get these extremes of hot and cold? Well, that simple question is the big mystery we're going to unravel today.
So first things first, we have to understand the small stuff, the daily drama that we call weather. Before we can get to the beautiful, predictable rhythm of the seasons, we got to decode the seemingly random, temperamental behavior of the atmosphere right above our heads.
And at the heart of pretty much all weather is this one process. It's super simple. The sun's heat turns water into vapor. That's evaporation. Then that vapor rises up, gets cold, and bam, it forms clouds. That's condensation. And when those clouds get full and heavy enough, the water falls back down as rain or snow. That's precipitation. This is the little engine that's driving our daily forecast.
So how does that engine actually work? Well, it kind of helps to think of the atmosphere as having two basic moods. You've got high pressure, that's the calm, happy one. The air is sinking, it's stable, and you get those beautiful, clear blue skies. But then you have low pressure. Oh, that's the dramatic one. The air is rising, it's unstable, and it brings all the action. The clouds, the rain, the storms. And the constant battle between these two moods, well, that's what we call weather.
Okay, so we've got the local picture down. But our weather, it doesn't just pop up out of nowhere, right? It's all part of this massive, interconnected global system. So now it's time to zoom out and look at the whole planet as one giant engine.
And every great engine has its gears. For Earth's weather machine, these are the big ones. First, you've got the sun, which is the power source. But it heats the planet unevenly. The equator gets blasted with energy, while the poles barely get any. Second, the Earth is spinning constantly. And this spin puts a twist on everything that moves, which we call the Coriolis effect. And finally, when you combine that uneven heating with the spin, you get these enormous, high-speed rivers of air way up in the atmosphere called jet streams.
So here's the bottom line. All those gears are working together to do one main job. They create this planet-sized conveyor belt, and its whole purpose is to try and balance things out by moving all that intense heat from the hot equator up toward the freezing poles. This is what literally moves storms and weather systems across entire continents.
So now we get it. We understand the chaotic engine of daily weather. But how does that connect back to the big question we started with? What about that predictable, year-long cycle of the seasons? This is where we find the real, elegant, and surprisingly simple truth behind it all.
Right, that global engine explains why a storm that starts in the Pacific can end up over Chicago a week later. But it doesn't explain why Chicago is buried in snow in January and scorching hot in July. What's the master switch that controls that huge change? This is it. This is the answer. It's probably the most important number in this entire story, 23.5 degrees. That one number is the reason we have summer, winter, spring, and fall.
That number, 23.5 degrees, is our planet's axial tilt. Just imagine a giant pole going right through the Earth from the North Pole to the South Pole. That pole isn't straight up and down. Nope, it's permanently leaning over at a 23.5-degree angle. And here's the part almost everyone gets wrong. The seasons have nothing to do with Earth being closer or farther from the sun. It is all about that angle.
And here's a perfect way to picture it. Imagine you have a flashlight. If you shine it directly at a wall, you get a small, bright, really intense circle of light, right? That's summer. But if you take that same flashlight and shine it at an angle, the beam spreads out. It gets weaker, dimmer, less intense. That's winter. The sun's energy works the exact same way. So now we can put all the pieces together. This constant, unwavering tilt combined with our year-long trip around the sun creates this perfect, predictable clock, a clock that dictates the entire rhythm of life on our planet. Okay, let's just follow the Northern Hemisphere for one full year. During our summer solstice, our part of the world is tilted directly toward the sun. We're getting that intense, direct flashlight beam. Then, as we orbit, we get to the autumnal equinox, where our tilt is just sideways to the sun. After that comes the winter solstice. Now we're tilted furthest away from the sun, getting that weak, spread-out beam. And finally, the spring equinox, where we're sideways again, on our way back to summer. The tilt itself never, ever changes. Only our location on the journey does.
And this really just says it all. It's this beautiful paradox, isn't it? The permanent, unchanging lean of our planet is the one thing that drives the constant, cyclical change of our seasons. The tilt is the reason for the season. Simple as that.
And just like that, we've come full circle. All that day-to-day, moody, chaotic weather, the high and low pressures, the wind, the rain, it's all just playing out on a giant stage. And that stage is set by the slow, steady, and totally predictable ticking of nature's cosmic clock, all governed by that one simple 23.5-degree lean.
So we've seen how the rhythm of our planet is run by this incredibly precise and reliable clockwork. It's a system that's been stable for a very, very long time. Which really just leaves us with one last kind of crucial question to think about. Nature's clock is precise, so what happens if its timing begins to shift?